Hello students, good morning. Today I am going to touch upon an important aspect of hardness of water, and that is about how to express hardness of water in equivalence of calcium carbonate. What I want to show you here is calcium carbonate is chosen as the reference because its molecular weight is a round number which is 100, and which becomes very handy in many calculations, which soon I am going to teach you how to do. So let's see. Hardness causing salts are the ones which are given here: calcium bicarbonate, magnesium bicarbonate, calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, and there are many non-hardness causing salts like sodium chloride, potassium chloride, sodium sulfate. All sodium and potassium salts I have told you already in the class. Okay. Now, how can you express the hardness of substance in equivalence of calcium carbonate? So, there is a very simple equation which is available for us. The equivalence of calcium carbonate is equal to mass of the hardness producing substance multiplied by a factor. So, the numerator is the chemical equivalent of calcium carbonate and the denominator is the chemical equivalence of the hardness producing substance. What does it mean? For example, let us say I have 100 milligrams per liter concentration of calcium bicarbonate. Okay. So, this value 100 milligrams per liter can be converted into calcium carbonate equivalence using this particular formula. Okay. The mass usually is expressed in milligrams and the hardness is expressed usually in milligrams per liter or ppm, which I have already taught you in the class, in the last class. Okay. So, coming to the factor that we looked at, we saw that the numerator contains the chemical equivalence of calcium carbonate, which is 100, or actually it is 50 because that is the chemical equivalence. But in most cases where divalent salts are used, you can conveniently use the molecular weight itself. Okay. So, the multiplication factor becomes 100 by 162 for calcium bicarbonate. 100 is the molecular weight of calcium carbonate and 162 is the molecular weight of calcium bicarbonate. So, you take this value, this 100 by 162 and multiply it by the amount of the substance that has been given to you. So, the rough example that I gave you was 100 milligrams. So, it will be 100 multiplied by 100 by 162, and whatever value you get, that is expressed in terms of calcium carbonate equivalence. Okay. So, this table gives you the multiplication factor for many such substances. For example, calcium bicarbonate, magnesium bicarbonate, calcium sulfate, calcium chloride, magnesium sulfate, magnesium chloride, calcium carbonate, magnesium carbonate. All these substances can be estimated by analyzing a sample of water. Okay. So, let us do some exercise so that we have a clear picture of what we are learning here. Okay. So, here is a question: express the concentration of the following in terms of calcium carbonate equivalence. So, let us take the first one, 81 milligrams of calcium bicarbonate. Okay. So, let us recollect the formula. This is the formula: equivalence of calcium carbonate is equal to mass of the hardness producing substance multiplied by chemical equivalent of calcium carbonate divided by chemical equivalence of hardness producing substance. Let us look at each of these values. Mass of the hardness producing substance for the first one is 81 milligrams. So, it is 81. Chemical equivalence of calcium carbonate is 100. Okay. And the denominator, chemical equivalence of the hardness producing substance, in this case calcium bicarbonate, is 162. Please make sure that your 100 should never come in the denominator. Please remember that. Many times I find students making this mistake, but somehow they confuse it with calculation of some percentage values, and they put the 100 in the denominator, which is absolutely wrong. You will go wrong when you try to do such thing. Okay, so let's apply this here. Yeah, so what happens, you have 81 multiplied by 100 divided by 162, which is equal to 50 ppm calcium carbonate equivalence. That's how you have to write. Okay, so keep these things in mind, and we will be solving many more problems. So what I suggest is you try to work out the rest of these substances which are given here using this formula, and in the class I am going to work out some problems and based on this principle.